Okay, so I'll start by giving a general overview of our process for designing user interfaces. And in recent years, we've reduced our our reliance and our use on more conventional UX and design tools, and we've incorporated Wolfram Language and Wolfram Notebooks more into that process, and we found that beneficial. And I'll explain why and illustrate with an example. And then I will end with just some other useful, Wolfram Language and Notebook features that we use in our workflow. Okay, so the usual process that we employ for creating a UI. So we identify that a UI is needed for a certain task, a certain feature, and we identify, okay, so these are the aims. This is what it should achieve. These are the features it needs to have, and then this diagram shows them the core process of how that UI is then created. So usually UX will start off, look at the aims, look at the features, and sort of work out, okay, this is how the user is going to interact with this interface. These would be the user flows. This is sort of roughly where everything should be laid out. And then we give those designs and those wireframes to graphic design, who then work their magic and make it look beautiful and make it look consistent. And then those specifications are handed to the developers for implementation. Now, in very sort of trivial projects, those pretty much are just the 3 steps in that order. But for anything more complicated, there is always sort of communication between these different steps, right? So we will pass we'll pass a wireframe to graphic design, and they will have opinions on how things should look, and that will change the user interaction slightly. And so there are these iterative loops, and then especially when the thing goes to the developers, and we've planned for it to work in a certain way, but then we're faced with the reality of certain implementation restrictions or difficulties or whatever, and so the whole process is sort of formed of these iterative loops of one team sort of going back to a different one. And what we found is that our tech has really helped speed up those iterations. And I should also mention on this slide that obviously at Wolfram, these are 3 teams, right? So these are 3 groups of people. But even if you are just designing an interface, figuring out how an interface should work, you're probably doing these 3 steps in your head, right? So you sort of have an idea of what it should do, you figure out roughly how it should work, you figure out roughly how it should look, and then you go to implement it. And then you are also probably doing these iterations where you sort of go back and you've implemented a bit and then you need to change the appearance slightly and that sort of thing. So hopefully this exposition of what we do will also help you. Okay, so a really important part of where these efficiency gains have come from is that the development and the deployment environments are the same, and they are notebooks. And so I'll just kind of point this out because it's not necessarily obvious. But the vast majority of our interfaces are actually written in top-level Wolfram language. And so these might be things like palettes or dialogues or even the welcome screen. And all those things are actual notebooks, and now they've just had various options set on them so that they don't look like notebooks, but they are notebooks. Or they might be UI elements such as the default notebook toolbar. That, believe it or not, is just a big top-level Wolfram language expression. And actually, there was a talk I did a couple of years ago on how that's implemented, if you're interested. Entities, output size limiters, all these sorts of things. They're not like C++ constructs. They're literally just Wolfram language expressions. And so, what this means is that we have a very powerful language for making these sorts of interfaces. And so when we are designing a UI, if we are able to implement a prototype or prototype parts of it fairly early on in the process, then we can kind of manipulate it and permute it in real time. And that makes sort of collaboration between all those 3 different steps much easier. Okay, so to kind of illustrate this, I'm going to look at a specific example from a specific project that we were working on for 14.2. And so we've been working on some new assistance features. And so I'll show you the project notebook that we have in a second. But one point I want to make is that, obviously we can talk about, the development of these interfaces and the deployment, and how notebooks are useful for that. But also there's just the point that notebooks are really useful for organizing things because they can store all these different types of content. So if I go over to our project notebook here, you can see that, yeah, so we have this project notebook, we keep everything organized. Every time we iterate, every time we have a version, we store that in here. And so, as the project goes on, you get lots of different sections and all the different notes for various different things. But I'm going to go all the way back to the first version. So there was this feature that we wanted that was basically content suggestion. So if the insertion point is in expression, and you invoke this interface, then you're going to get a little loading indicator, and then you're going to get a little interface that pops up with various different suggestions of code completions in this case, and you can arrow up and down those and select one, and it will insert, and then the interface is dismissed. Okay, so so this part here, this sort of very initial version, this is obviously not done in Wolfram Language at this point. This is just this is the first step. So you would just use whatever program you find easiest to use. So we did these in Illustrator, in Adobe Illustrator. But the point is that you have an idea for how this thing should work, and then you're just trying to quickly get down, okay, how is this going to work? What is it going to look like? At the point at which you have that, you can then try and make a quick prototype in Wolfram Language to see if it really does behave as you think it would behave. So you don't have to sort of imagine it. You can sort of test it. So let's do that. So we'll make a quick prototype of this raft. So it's the usual front-end suspects, right? So we're going to make use of to lay the thing out. We're going to use like column and frames and grid and whatnot. We want it to have some dynamic capability, so we're going to use things like dynamic module and event handler to track user interactions, and then we'll use button and notebook write to actually insert the suggestions. So okay, so let's build this up. So we have those lists of items, and so a specific suggestion in this would be the label, right? So that's called label, and then we're wrapping a frame around that label. And if you recall, like the top suggestion, that interface had like a red highlight, and so the idea is that you've got a selection state. one of those things is selected, and so we're going to track that with this dynamic selection variable here. And so all we're saying is that if the selection state is basically the same as this item's index, then draw a red frame, otherwise draw a gray frame. And then we're wrapping that whole item in an event handler, so that when the mouse enters that event handler, the selection state is set to the index for this item. So I'll evaluate that. Then we want to put those items in a column, and so here's our item. Actually, the first thing we need to do, obviously, is that when you click on one of those, you do want it to insert the selection into the notebook. And so the action of this button, we're going to use notebook write to just write, the basically #1 is that label, right? So these things here, we're going to write that into the notebook. And then after we've done that, this interface is going to be attached as an attached cell, and we want to take that interface away once we performed the insertion. So we just call notebook delete of evaluation cell, and that will take the interface away. Yeah, and so I've just got some example inputs here. The point here obviously is that we're not working on the back end of this, and we're just like designing the interface. So I've just put some example suggestions in. Great. Okay, so let me evaluate that, and we can see what that looks like. And so, yeah, we've pretty much built up like a very crude prototype of our raft with really sort of hardly any code here. Okay, so now we actually want to attach it to the insertion point so we can test it and see if it works as we expected. So new in 14.1, attach cell can actually attach to selection. So the first argument here can take notebook selection. So I'm making a button. The attachment point is a notebook selection. I'm attaching the mock that we just made. Then I've got some alignment arguments, and then the removal condition as well. So let's evaluate that, and let's try it. So I'm going to place the insertion point here, and then attach the mock. And great, okay, we can see that we've got our raft. And yep, seems to work as expected. If I click one of these, there we go, it inserts. So okay, let's, we've got this, we may as well play around with it. Let's try a slightly different example. So let's put the insertion point here. This example is just a bit longer. Attach, and oh, okay, so we've come across something that we didn't necessarily anticipate when we were sort of laying out in our design, which is that, okay, these rafts can get clipped by the edge of the notebook. Now, obviously, this is a relatively simple example that I guess we probably could have thought about beforehand. But the point is that it's showing, as soon as you've got a prototype that you can play with, you start finding these little things that you didn't necessarily expect. Okay, so right, so we have this clipping issue. So there are several different things we could do to solve this. And the one that we decided to go for various reasons was make the raft full width and center align it with the notebook. Sorry, with the window. And actually, I think new in 14.2, so this is coming, attach cell for the alignment arguments can now take window centered and window left and window right. So we can make use of that. So all I'm going to do here is just alter the enclosing frame, right? So I've got exactly the same code as I had before. All I'm doing is just adding an image size option to the bottom to say the width should be full. And then I'm adding some absolute padding on either side. So it's just not like the complete width. It's, sort of contained nicely. So I'll evaluate this. And there we go. And now same attachment code as before, except that I'm just changing the alignment slightly, right? So I'm now aligning to the window center. So evaluate this. And then here was our troublesome example. So if I put the insertion point in the same place and attach the mock, there we go. And I think this solution is relatively reasonable. Yeah, okay. So yeah, with a very quick and basic Wolfram language prototype, we were able to test the idea that we had and identify a problem and then iterate on it. And we did this with very few lines of code, and we did it very, very quickly. Now, with a bit more work, we can add the other features of the Illustrator mockup we had before, right? Because it had like an input field at the bottom and also had like a little loading indicator to begin with. So I'm not going to go through like all of the steps of how that's made because it's a bit more code, but the general structure doesn't change. So the first thing I'm going to do is just define some of these loading indicators, and I've given these little sort of directional pointers. I'm calling them carrots. These are nothing but dynamic graphics expressions, really, so nothing particularly complicated here. Then again, we need to make the column of suggestions that we had before, and all I'm doing now is adding an input field to the bottom. So that's an input field. And the main difference between this slightly more advanced prototype and the one we had before is that because we've now got multiple things that need to attach as multiple attached cells, right? So we've got like these little pointers, these carrots. Then we've got the main interface, and these need to attach at different times. We now need some code to manage the attachment of those cells and their state. And so that's what the state manager function does. And all it's doing is taking the state, it's taking the two caret states, right? So these guys as its arguments. So yeah, as before, we're calling attach cell to attach a prototype to the selection. So that doesn't change. Notebook selection. The actual thing that we're attaching is now given by state manager. And the removal conditions now are also actually managed by state manager. So if I evaluate this, and then as I put the insertion point there, for example. Okay, so now we get the loading indicator to begin with, and then that will resolve into our raft of suggestions. And we've got the input field there. So we can now, now that we have this slightly more advanced prototype, we can play with it a bit. And we can do that because the overall structure didn't change, right? It doesn't matter how complicated the package behind what you're building gets, as long as it's sort of structured relatively reasonably, and it all still sort of filters down to the same like attachment code and things like that. You can still modify that in the same way and just as quickly. So one thing we might want to do is, okay, maybe we don't like where that caret position was right below the insertion points. Well, let's try and change that. So this is exactly the same code we had before, and so let's make that modification. So rather than let's say rather than pointing up at the selection, we put it at the side of the notebook, and it points to the right. So rather than using the loading caret, if you remember, I had versions where the caret pointed up and versions where the caret pointed to the right. So I'm just going to change. I'm just going to use the right pointing. Whoops, the rightwards pointing ones. And then I just need to change the alignment slightly. So rather than aligning to the center of the selection, I'm going to align to the left of the window. So window left. May as well align to the center of the selection now. We don't need an offset, and the left hand. So this is the alignment of the child. So we need the left hand edge of the caret to align with the left of the window. So I evaluate this. I place the insertion point again, and there we go. This now is positioned on the left, and it has all the same behaviors as before. So this prototype got more complicated, but it was still very easy to sort of iterate on and test different versions of it in real time. Okay, so using your tools efficiently. So for the initial sort of mock-up that we did to just get the idea down, what I'm not saying is, we should be using Wolfram Language for everything from the very beginning. No, use the sort of the appropriate tool for the appropriate step. So as I said, if you're just trying to get something, an interface down or something, an idea, then even pen paper might be, your most efficient way of doing that. But then very early on in the process, we were able to implement a quick prototype using Wolfram Language, and I really would emphasize quick. It was only a few lines, our initial one, so that we could assess the effectiveness of the design in situ as well, right? I mean, this is going to be deployed in notebooks, and we were able to see it in a notebook, and then we could find those issues and fix them. And then now that we sort of have figured out that, okay, yeah, we're kind of happy with the core behavior, we can see how this will work. Now we can change back to, I use Illustrator, but whatever it might be, to then rapidly mock up things like aesthetic changes. So this is what we might end up with. We've just added some other elements around here. Okay, so I said I'd end with some other sort of Wolfram Language and notebook features, notebook programming features that we have found useful in our workflow. Yeah, one is that Mathematica is very good at communicating with other sources of data, right? And so there's this resource function, SVG import. I think this is written by Rick Hennigan. And what this means is that it's very, very easy to work with assets from packages like Illustrator, because Illustrator will copy things to the clipboard as SVGs. And so, I can go to Illustrator and I've got this icon that I was working on. And so I can literally just, Command C, copy this. I can paste it directly into Mathematica. I'll just iconize that because it's a relatively long string. Evaluate this, and I've got the icon in there. And I didn't need to sort of take a screenshot. I didn't need to export the thing into a directory and then look that up. I could literally just use the clipboard. And this is now like a Wolfram Language graphics expression, and so we can just manipulate it in the usual ways, right? And so you can actually see that this edge here has got clipped slightly, and so I can just add some image padding to fix that and redefine our icon. Okay, so now that we've got that icon in Mathematica, we can now make use of it. And to do that, I'm going to use cell options and tagging rules. And what tagging rules allows you to do is is essentially stored data associated with a cell or a notebook, such that it will serialize, right? Because I could use this icon by storing it in a kernel variable, but of course, when the kernel dies, I'm going to lose my icon. Tagging rules gives us a way to permanently store things in a nice organized way in a notebook. And so to do this, I'm going to use current value. So I'm setting this tagging rule on the evaluation notebook. I use the option tagging rules, and then I've got a tag and a sub tag, and I'm going to assign the icon to that. And then I can use absolute current value of that same tag to read it, and there we go, there's our icon. Yeah, now we can assess how the icon works in situ. So you know, we're developing these assistance features, and so you know, in order to sort of you know, show people where they can be used, we might want to attach such a button to like a message cell, for example. And so here I'm using set options on the previous cell, so that's this cell here, and then I'm setting an initialization so that when the cell is drawn, it will attach this icon to the left of this cell. And so the attachment point is the evaluation cell, which would be this. And then I'm really just attaching, you know, what we had before, right? So absolute current value of the tagging rule, and then I've wrapped that in dynamic. So I'll evaluate that, and we can see this has appeared here. And the nice thing about this is that because we wrapped, this tagging rule in dynamic, I can change the definition of that tagging rule and everything will update, right? So say I was, you know, putting this on like various different cells throughout the notebook, I can just change its definition, updates everywhere. So maybe I want to use a different icon. Here I'll keep it simple, and I'll keep the same icon, but I'll just, you know, label it with help, for example. So I will, oops, my scrolling's got stuck. There we go. So I'll evaluate this, and this guy will update. There we go. And then, of course, I mean, from here, you could then actually start building an interface up, right? So I can wrap this in button, I could make it beep or whatever. Whoops. And so now this has become a button and it beeps. Yeah, so, okay. So in summary, we saw how many of the, in fact, the vast majority of front-end interfaces are actually written in Wolfram language. They are top-level expressions. And what this means is that if we are able to implement a prototype UI, which we were able to do in very few lines and very quickly, then we can manipulate it and permute it in situ. And so this kind of enables the sort of the seamless you know, iteration process where we're going from sort of you know, development to testing back to development. And yeah, we were able to implement this with only really a pretty small number of key functions. And so, you know, we had some dynamic stuff, we had things for handling user events, we had some functions for laying things out, and then we had some notebook programming functions, and that's pretty much it. And the last point I'd make is that yeah, notebooks, they're just very, very powerful in the sense that you can, you know, you don't just, they're not just for like writing code and you know, developing these UIs in that way, but you can sort of store everything, all the assets that you have, all the mock-ups that you've done, any images that you need all together. And so you've got a nice narrative of how this thing came together, which is very useful for collaboration and sharing with other people. Yeah, thank you very much. I hope you found that useful. Right, now let me check the questions. Let's see. Okay, we have some questions. So Dave G asks, you mentioned that UI elements are notebooks, but with some things set on them so they don't look like notebooks. What are these things that are set so a UI element doesn't look like a notebook? I don't understand a UI element being a notebook. So I was trying to sort of draw a distinction between two different categories. So some of these things are actual notebooks. So for example, how do you get there? The welcome screen. Right, okay, so this is a notebook in the sense that, you know, this is represented as a big Wolfram language expression with head notebook and a list of cells and a bunch of options at the end. And it's just formatted by the front end, you know, in this way. And in that sense, it's no different from, you know, like this notebook, for example. the things that I was referring to specifically that make it not look like a notebook are options. And so, for example, I'll just make a new, right, so notebook, options of notebook. Right, and this is going to be incredibly long. In fact, let's just take let's just take the option names. There we go. Right, so these are all of the options that you can set on notebooks, and they're going to determine, you know, if the toolbar is shown, if the thing is savable, if the notebook is resizable, even if like the system toolbar, the system Chrome at the top is shown, the opacity of the notebook, whether it floats, on top of all the others, all these sorts of things you can set by going through all these notebook options and finding the appropriate one and setting that. So, for example, they're savable. For example, so like the welcome screen and palettes, they would all have savable sets of false. When I was talking about UI elements, I meant things that sort of appear in notebook content. So, for example, something like an entity. So this obviously isn't a notebook in and of itself, but it is just a Wolfram language expression that is written in top level code. Okay, we've got another question from Michael. Are there any new ways to affect smooth spatial animations or transitions in cells or graphical interface elements? We don't have any new, at least that I'm aware of, we don't have any new sort of C++ features that have been implemented that in other words, things that we've exposed in top level to sort of animate cells in the way that I think you're describing. Yeah, I mean, you could do things like you could wrap the contents of a cell in style and set the opacity of all that content. Style of framed of hello, opacity, or is it content opacity? Content opacity. I can't remember the name of the option, but there is an option that controls this. Or maybe it applies to cells. You might have to wrap this in a cell and do it. But the point is, whatever that option is, the right-hand side could be dynamic and linked to a variable that you're then animating, I suppose. Yeah, I mean, without knowing exactly what you have in mind, it's difficult to sort of give specifics. But what I would say is that attached cell, so this function that I was using to take arbitrary content and sort of just put it in an arbitrary place in a notebook, that's very, very powerful. And we're adding, which I think John Fultz will probably talk about in his State of the Front End talk. We've added a bunch of functionality to that may be useful for you in terms of moving things around or trying to make transitions. You might be able to use attached cell depending on exactly what you're trying to do. Okay, I think that's it for the questions. And let me just check the chat as well. Jason, thank you. Yeah, I think that's it then. If you have any more questions, I will, if you think of something later, add it to the Q&A or message me directly, and I'll respond in writing. Okay, thank you very much.